We used to believe we understood the scale of the cosmos. Back in 2004, when the Hubble Space Telescope unveiled its ultra-deep field, humanity stared into a tiny, empty-looking patch of sky and discovered 10,000 galaxies glowing in the darkness. That image changed everything. Astronomers used it to estimate there might be 2 trillion galaxies scattered across the observable universe. For a generation, that was our cosmic map, vast, humbling, and complete, or so we thought. But Hubble's masterpiece was also a limit, a snapshot through a keyhole. It showed us beauty, but not the whole truth. What it couldn't see was hidden behind veils of cosmic dust and buried deep in the infrared shadows of space, where the first galaxies slept unseen. Then, 2 decades later, a new set of eyes opened, eyes sharper, colder, and infinitely more powerful. The James Webb Space Telescope didn't just take Hubble's place. It rewrote the rules of seeing dot in one breathtaking 150-hour campaign known as the Cosmos Webb Mosaic. Webb shattered every boundary we had. Where Hubble once found 10,000 galaxies, Webb found nearly 780,000 in a patch of sky no larger than 3 full moons. Each one, a glowing island of billions of stars. Each one, a whisper from over 13.5 billion years ago, when the universe itself was barely a toddler. The revelation wasn't just about numbers. It was about structure, maturity, and the eerie question that followed. How could so much complexity exist so soon after the Big Bang? It was as if the cosmos had evolved faster than our physics allowed. To understand the magnitude of what Webb accomplished, you have to go back to Hubble's first great leap. In 2004, astronomers pointed Hubble toward a patch of sky in the constellation Fornax, a region that looked completely dark. For over 11 days, Hubble gathered every photon it could. When the image was finally processed, the empty void came alive. Thousands of galaxies, some formed less than 1 billion years after the dawn of time. That one picture became the most famous window in astronomy, the Hubble Ultra Deep Field. Every dot of light was not a star, but an entire galaxy, each holding billions of suns and countless worlds. From that single image, we built our understanding of how the universe expanded, aged, and gave birth to structure. But there was always something missing. Hubble's 2.4-meter mirror could only see visible and ultraviolet light. The light from the earliest galaxies had been stretched by cosmic expansion, slipping into the infrared spectrum beyond Hubble's sight. And much of that ancient starlight was trapped behind curtains of interstellar dust. Entire populations of galaxies remained invisible, hidden in plain sight. Hubble's deep field wasn't the edge of the universe. It was just the edge of our vision. Then came Webb, with its 6.5-meter golden mirror. It collects more than 6 times as much light, but the real miracle lies in its sensitivity to infrared wavelengths. Webb doesn't just see through dust. It pierces the cosmic veil, catching the faint, stretched whispers of galaxies born when the first stars were still igniting. Where Hubble's vision was like peering through a keyhole into eternity, Webb's is like stepping back to behold the entire cathedral of creation. To put the difference into perspective, if Hubble's ultra-deep field were a single photograph on a sheet of paper, Webb's Cosmos Webb Mosaic would be a mural 13 feet wide and 13 feet tall, packed with structure, color, and unimaginable depth for over 150 hours. Webb stared into that cosmic canvas, 3 full moons worth of sky, taking thousands of exposures. Scientists stitched those fragments together into the largest and deepest panoramic map of the universe ever. Created. Inside that single image lie nearly 780,000 galaxies, some formed just for 100 million years after the Big Bang. Together, they trace the cosmic web itself, glowing filaments, vast voids, and tangled clusters that span billions of light years. This isn't just a bigger picture. It's a new kind of atlas, one that lets astronomers witness not just isolated galaxies, but the architecture of existence itself for the first time. We can see how the universe grew up, from its turbulent infancy to the sprawling web of light and matter we live in today. And in that web, stretching endlessly across the dark, we may finally glimpse the truth of our cosmic origins and how impossibly vast, impossibly alive, the universe really is. In Webb's vast cosmic map, the familiar begins to blur into the extraordinary. Across billions of light years, the Cosmos Webb Mosaic reveals not a random scatter of galaxies, but a living architecture, grand spirals spinning in silence, smooth ellipticals glowing like cosmic pearls, and irregular galaxies caught mid-collision, frozen in moments of unimaginable violence. For the first time, Astronomers can trace how these systems gather, like cosmic rivers of light, flowing together into titanic filaments and clusters. These filaments form the backbone of the cosmic web, the very structure upon which the universe itself is built. But amid this breathtaking order, one discovery stands apart, something so strange, so perfectly timed, it feels almost scripted by the cosmos itself. They call it the infinity galaxy dot from a distance. It appears as a glowing figure 8, to massive disk galaxies colliding nearly head-on. Their spirals intertwine like celestial dancers locked in a fatal embrace. Each galaxy remains visible as a compact red core, surrounded by shimmering rings of gas and stars, their shapes twisted and stretched by gravitational tides. This collision, estimated to have begun 50 million years ago, is more than a spectacle of cosmic destruction. It's a laboratory of creation, a rare snapshot of forces that forged the universe's most mysterious engines. Between the two glowing hearts of the colliding galaxies, Webb's infrared vision picked up something astonishing, a vast cloud of ionized hydrogen, glowing brighter than theory allowed. At its center, buried deep within the gas, lurks a hidden power source. Follow-up observations with NASA's Chandra X-ray Observatory confirmed it, a supermassive black hole, roughly 1,000,000 times the mass of our Sun, sits not inside either galaxy, but in the space between them, floating in the void, feeding on the chaos around it. Its motion matches the surrounding gas within 50 kilometers per second, meaning it's not a runaway or a captured wanderer. It was born there, in place, from the shock of the galaxy's collision itself. This off-center black hole is joined by two more, one in each original galaxy. 3 black holes, all active, all devouring matter, and all burning brightly across space-time. It's the first clear glimpse of a triple black hole system caught mid-formation, a direct window into how supermassive black holes might see themselves in the chaotic hearts of merging galaxies. For astronomers, the infinity galaxy is more than a discovery. It's a revelation, a single frame that reshapes our understanding of where and how the universe's most massive engines come to life. Only a map as wide and deep as Webb's could have revealed such a fleeting event, a moment of collision and birth. Frozen across 10 billion years of light, that luminous figure 8, glowing across the void, may one day merge into a single galaxy with a single titanic core, but for now, it stands as a snapshot of creation caught in motion, and beyond it, Webb's gaze pushes deeper still, into an era astronomers call cosmic noon. Roughly 10 billion years ago, this was the universe's age of fire, when stars were being forged at the fastest rate in cosmic history. But what Webb saw there wasn't chaos. It was order. Across the field, galaxies gleamed like jewels, disciplined, organized, mature. Webb's infrared vision reveals something almost paradoxical: massive galaxies that have already stopped forming stars, sitting silently in a universe that should still be raging with creation. These are the so-called quenched galaxies, enormous, ancient systems that seem to have burned through their fuel too quickly, falling quiet long before their time. Some are as massive as the largest ellipticals in today's universe, yet they existed when the cosmos was still young. Even stranger, Webb has uncovered spiral galaxies with perfectly defined arms, their disks stable, their structure symmetrical, at redshifts between 2 and 3. Just a few billion years after the Big Bang, according to our models. It should have taken far longer for gravity to sculpt such order from the cosmic storm, and yet, there they are, spirals winding gracefully, some with central bars cutting across their hearts, features that signal maturity, stability, and time, the kind of time these galaxies shouldn't have had. This early order changes everything. It means the universe was building complexity faster than anyone imagined. The mechanisms that formed and quenched galaxies, that shaped their structure and silenced their stars, were operating with incredible speed. Each galaxy captured in this epoch is a clue, a piece of evidence in a mystery that stretches across all of time and space. Together, they tell a story not of slow evolution, but of a universe in overdrive, racing towards structure and beauty far ahead of schedule. The Cosmos Webb mosaic isn't just a deeper view of space. It's a new kind of history book, written in light, showing us that the universe didn't just grow up. It leapt from chaos to order, from dust to galaxies, from nothing to everything. And as Webb peers even further back, one question begins to echo louder than ever: if the universe built this much, this fast, what else is waiting for us to find? At the farthest edge of what the James Webb Space Telescope can see, the universe itself begins to blur into mystery. There, in the faintest glimmer of red-shifted light, astronomers have found the record holders of existence, galaxies so distant, so ancient, that their light began its journey when the universe was barely awake. The first is Jade's GSZ 140, a fragile ember from only 290 million years after the Big Bang. Not far beyond it lies MAMZ 14, shining from just 280 million years after everything began. Their distances are not guesses. Webb's near-spec spectrograph has locked them in place with razor-sharp Lyman break signatures, the cosmic fingerprints of age and truth. But what stunned astronomers was not their distance. It was their maturity. When the ALMA observatory tuned its arrays toward Jade's GSZ 140, it detected oxygen emission lines, proof that heavy elements already existed at this unimaginably early time. That means at least one entire generation of stars had already lived, burned, and died, scattering metals across space before these galaxies were even born. Each one blazes with the power of hundreds of millions of suns, compressed into compact, furious starburst regions. Tiny furnaces turning raw hydrogen into light and metal. Their existence defies the standard cosmic timeline. In the first 300 million years, the universe wasn't idle or empty. It was furiously building, running a race against time itself. The discoveries pouring in from Webb's new map are forcing scientists to rewrite the story of creation. Galaxies and black holes appear to have formed earlier and faster than any model dared predict. The cosmos we thought evolved slowly now looks more like a cosmic sprint, a rapid cascade of star birth, collapse, and rebirth compressed into mere moments on the universal clock. The old story was a slow ascent, from simplicity to structure, from gas to galaxies, from darkness to light. Now, Webb reveals something different, a universe in overdrive, forging complexity almost as soon as it existed. The pace of ionization, the growth of massive halos, the seeding of black holes, all of it must be reimagined. The earliest epochs of cosmic history, once hidden beyond reach, are being rewritten line by line, and every new image, every spectrum, adds another verse to a song we're only beginning to hear. In just 250 hours, Webb's Cosmos Web Survey mapped nearly 780,000 galaxies, more than 80 times what Hubble's ultra-deep field showed in 2004. This vast infrared panorama stretches back 13.5 billion years, capturing spirals, mergers, and starbursts in every stage of evolution. Among them gleam record breakers like Jade's and MAMZ 14, their light reaching us from when the universe was less than 2% of its current age. And yet, for all its depth, this monumental survey covers only a tiny patch of sky, a fraction of what's out there. If that one field contains nearly 1 million galaxies, how many fill the rest of the heavens? How vast, how crowded, how alive is the universe we inhabit? Even now, Webb's golden mirrors keep watching, drinking in the first light of creation. Photons that have traveled longer than time has meaning. Each one is a whisper from the beginning, a reminder that the cosmos is still writing its story, still evolving, still inviting us to understand dot. And as we stare into that infinite mosaic, into galaxies that existed before galaxies should exist, we begin to realize a truth that feels almost spiritual. The deeper we look into the universe, the more it looks back.